Chapter 11, Security, Authentication, and SPA. This chapter covers understanding the Spring Security fundamentals, managing user accounts with Keycloak, working with OpenID Connect, JWT, and Keycloak, authenticating users with Spring Security and OpenID Connect, testing Spring Security and OpenID Connect. Security is one of the most critical aspects of web applications and probably the one with the most catastrophic effects when done wrong. For educational purposes, I'm introducing this topic only now. In a real-world scenario, I recommend considering security from the beginning of each new project or feature and never letting it go until the application is retired. Access control systems allow users access to resources only when their identity has been proven and they have the required permissions. To accomplish that, we need to follow three pivotal steps: identification, authentication, and authorization. 1. Identification happens when a user, human or machine, claims an identity. In the physical world, that's when I introduce myself by stating my name. In the digital world, I would do that by providing my username or email address. 2. Authentication is about verifying the user's claimed identity through factors like a passport, a driver's license, a password, a certificate, or a token. When multiple factors are used to verify the user's identity, we talk about multi-factor authentication. 3. Authorization always happens after authentication, and it checks what the user is allowed to do in a given context. This chapter and the next one will cover implementing access control systems in cloud-native applications. You'll see how to add authentication to a system like Polar Bookshop and use a dedicated identity and access management solution like Keycloak. I'll show you how to use Spring Security to secure applications and adopt standards like JWT, OAuth 2, and OpenID Connect. In the process, you'll also add an Angular front end to the system and learn the best practices for security when a single-page application, SPA, is involved. Note: the source code for the examples in this chapter is available in the Chapter 11/11 Begin and Chapter 11/11 End folders, which contain the initial and final states of the project. See this link. Section 11.1, Understanding the Spring Security Fundamentals. Spring Security, see this link, is the de facto standard for securing Spring applications, supporting imperative and reactive stacks. It provides authentication and authorization features, as well as protection against the most common attacks. The framework provides its main functionality by relying on filters. Let's consider a possible requirement for adding authentication to a Spring Boot application. Users should be able to authenticate with their username and password through a login form. When we configure Spring Security to enable such a feature, the framework adds a filter that intercepts any incoming HTTP request. If the user is already authenticated, it sends the request through to be processed by a given web handler, such as a REST controller class. If the user is not authenticated, it forwards the user to a login page and prompts for their username and password. Note: in imperative Spring applications, a filter is implemented as a servlet filter class. In reactive applications, the web filter class is used. Most Spring Security features, when enabled, are handled via filters. The framework establishes a chain of filters that are executed according to a well-defined and sensible order. For instance, the filter that handles authentication runs before the one that checks for authorization because we can't verify a user's authority before knowing who it is. Let's start with a basic example to better understand how Spring Security works. We want to add authentication to the Polar Bookshop system. Since Edge Service is the entry point, it makes sense to handle cross-cutting concerns like security there. Users should be able to authenticate with a username and password via a login form. First, add a new dependency on Spring Security in the build.gradle file for the Edge Service project, Edge Service. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 11.1, Adding dependency for Spring Security in Edge Service.
The central place for defining and configuring security policies in Spring Security is a Security Web Filter Chain bean. That object tells the framework which filters should be enabled. You can build a Security Web Filter Chain bean through the DSL provided by Server HTTP Security. For now, we want to comply with the following requirements. All endpoints exposed by Edge service must require user authentication. The authentication must happen via a login form page. To collect all the configurations related to security, create a security web filter chain bean in a new security config class, com.polarbookshop.edgeservice.config package.
See this code?
The server HTTP security object, auto-wired by Spring, provides a convenient DSL for configuring Spring security and building a security web filter chain bean. With Authorize Exchange, you can define access policies for any request, called an exchange in reactive Spring. In this case, we want all requests to require authentication, authenticated.
See this code?
Spring Security provides several authentication strategies, including HTTP Basic, Login Form, SAML, and OpenID Connect. For this example, we want to use the Login Form strategy, which we can enable via the form login method exposed by the server HTTP security object. We'll go with the default configuration, available via the Spring Security Customizer interface, which includes a login page provided by the framework out of the box and an automatic redirect to that page whenever a request is not authenticated.
See this code?
Next, annotate the security config class with Enable WebFlux Security to enable Spring Security WebFlux support. The final security configuration is shown in the following listing.
Listing 11.2, requiring authentication for all endpoints via a login form.
Let's verify that it works correctly. First, start your Redis container required by Edge service. Open a terminal window, navigate to the folder where you keep your Docker Compose file, polar deployment/docker/dockercompose.yml, and run the following command.
See this code?
Then run the Edge service application /gradle-w-boot-run, open a browser window, and head to localhost 9000/books. You should be redirected to a login page served by Spring Security where you can authenticate. Wait a minute. How can we authenticate without defining a user in the system? By default, Spring Security defines a user account in memory with the username user and a password randomly generated and printed out in the application logs. You should look for a log entry like the following.
See this code?
You can authenticate with the predefined user account created by Spring Security. After successfully authenticating, you will be redirected to the /books endpoint. Since catalog service is down and Edge service has a fallback method to return an empty list when querying books, implemented in Chapter 9, you'll see a blank page. That's expected. Note: I recommend you open a new incognito browser window every time you test the application from now on. Since you're going to try out different security scenarios, the incognito mode will prevent you from having issues related to browser caches and cookies from previous sessions. The crucial point of this test is that a user tried to access a protected endpoint exposed by Edge service. The application redirected the user to a login page, showed a login form, and asked the user to provide a username and password. Then Edge service validated the credentials against its internal user database, auto-generated in memory, and, on discovering they were valid, started an authenticated session with the browser. Since HTTP is a stateless protocol, the user session is kept alive through a cookie whose value is provided by the browser with each HTTP request, a session cookie. Internally, Edge service maintains a mapping between the session identifier and user identifier, as shown in Figure 11.1.
Figure 11.1. After the login step, the user session is kept alive through a session cookie.
When you are done testing the application, terminate the process with Ctrl-C. Then navigate to the folder where you keep your Docker Compose file, polar deployment/docker/dockercompose.yml, and run the following command to stop the Redis container.
See this code?
There are a few problems with the previous approach when applied to a cloud-native system. In the rest of the chapter, we'll analyze those problems, identify viable solutions for cloud-native applications, and use them on top of what we have just implemented.